Right now, you're using a technology that neither America nor China actually wanted you to have. You're winning an AI race you didn't know you were in. The US tried to cut China off from the chips that build AI. What China did next didn't just get around that, it changed the AI tools sitting on your phone right now, and by the end of this, you'll see exactly how. That race turned into something nobody in Washington or Beijing actually planned for. Here's how the trap was built. In January 2026, US regulators rewrote the rulebook. A new formula for measuring a chip's raw power used to decide exactly which chips China would be allowed to buy. For the most advanced chips, the wall stayed up. But for the next tier down, chips capable of training serious AI, Washington did something almost nobody expected. It opened the door. Under a new 25% tariff, and after months of lobbying by the very company that makes them, millions of mid-tier chips got the green light to ship to China. It was controversial before the ink dried. Within a week, a bipartisan group of lawmakers was demanding it be undone. By the end of January, the House Foreign Affairs Committee voted 42 against 2, giving Washington back the power to approve sales like this. The wall Washington had just built had a door in it from day one. Washington wasn't the only side holding something back, though. China still had leverage of its own, the rare earth materials the rest of the world needs to build almost every electronic device. It had used that leverage before, then pulled back as part of a fragile truce. But the truce didn't last, and America still couldn't control that one critical choke point. Washington had its own leaks to plug, too. By summer, officials were still trying to close the gaps in their own rule. Some chips were reportedly getting into China through overseas subsidiaries, pushing Congress to close those gaps for good. Then came the part nobody predicted. By July, Beijing was reportedly drafting its own export controls on its own AI models and even its own chips. The country that had spent 2 years fighting to get this technology out from under restriction was suddenly worried about losing control of it too. Neither government actually wanted this technology moving freely. Both were still trying to control it, which made what happened next even stranger, because somehow the controls didn't stop the technology from reaching more people than ever. They pushed it out faster. While the two governments kept trading restrictions, a different fight was already underway inside the labs themselves. The biggest American labs, OpenAI, Anthropic, and Google, kept doing what had always worked: build the most powerful models, run them on the best chips available, and charge for access. But the Chinese labs couldn't play that game anymore. They didn't have the chips for it. So instead, one relatively unknown company tried something almost nobody expected. In January 2025, DeepSeek released a model that matched the giants and gave the weights away for free, under an open license that let anyone download it, modify it, and run it themselves. No permission required. Overnight, it sent a shockwave through the entire AI industry. What cracked wasn't the need for massive computing power, but the belief that only companies with billion-dollar server farms could build world-class AI. Other Chinese labs followed fast, but DeepSeek was only the opening move. Then, on July 16th, came the twist nobody saw coming. Moonshot AI, the same company from our opening, released Kimi K3, a 2.8 trillion parameter model, priced at a fraction of what Western companies charged per token. Just 10 days later, it released the full open weights, making Kimi K3 the largest open weight model ever released. And it wasn't just cheaper. On Front-End Code Arena, one of the industry's leading blind coding benchmarks, where developers compare anonymous models head-to-head, Kimi K3 took the #1 spot, ahead of every closed model on the leaderboard, including Claude Fable 5. The old order suddenly had a real challenger, and anyone could use it for a fraction of the price. That's the fight that actually mattered all along. Never just about chips. It's open models versus closed ones. Picture Claude Fable 5, Anthropic's flagship model, launched in June, as a cathedral. Magnificent, polished, built by a central authority. You're welcome inside. You just don't get to see how the walls were built, or move them yourself. Now picture the open weight movement as a bazaar. Every stall leaves its work out in the open. Anyone, a startup, a student, or a hobbyist halfway across the world, can build something new. And Beijing didn't just let this happen quietly. Weeks earlier, reports had surfaced of a $295 billion government bet on AI infrastructure built around domestic chip makers. Then, at a major AI conference in Shanghai, officials made the strategy explicit, calling open-source AI the country's advantage. Nobody expected this. 2 years ago, China's open-source AI meant playing catch-up. DeepSeek proved China could survive without the best chips. Kimi K3 proved something bigger. An open-weight model, built at a fraction of the cost, could climb within a few points of Claude Fable 5 on the industry's broadest AI benchmark. And it didn't stop there. It beat Claude outright on the one skill developers pay the most for: writing code. This isn't an underdog story anymore. By some measures, China now has a second AI superpower, and it just proved it in public. Kimi K3's win didn't just sit there. It moved the industry. Labs that had spent years competing only against each other suddenly had a new name to watch and a new price to beat. And here's the part that changes everything. All of this, the restrictions, the retaliation, the leaked drafts, two labs racing to outbuild each other, had quietly been working in your favor. When a developer anywhere can get near-frontier performance from a cheap, open model, companies charging premium prices can't charge whatever they want anymore. That pressure is one of the biggest reasons AI got cheaper this year, not more expensive. Something even stranger was happening at the same time. On the side that was supposed to be winning, weeks before Kimi K3 ever launched, the US government ordered Anthropic to pull Claude Fable 5 offline. Not over chips this time, over the model itself, citing national security concerns about its cybersecurity capabilities. Claude Fable 5 stayed offline for nearly 3 weeks. The wall didn't just aim at China. It swung back and hit its own side first. If you want to actually understand where this goes next, instead of just catching headlines about it, so that's what this channel does. Subscribe, and I'll keep tracking what these shifts mean for the tools you use every day. Because here's where it lands. You now have both a Rolls-Royce and a hot-rodded tuner car to choose from. Which one you reach for depends on the job, not your bank account. A student in Lagos or Sao Paulo can now open a laptop and run a model competitive with Silicon Valley's best. Through a free app or a cheap API call, with no subscription and no gatekeeper standing in the way. 2 years ago, that sentence wasn't true. So, did the export controls work or backfire? Even the experts don't fully agree. The best case for Washington? They likely slowed China's access to the most advanced chips, giving US companies more time to stay ahead. The complication? They may have also pushed Chinese labs to build faster, cheaper, and more openly than they otherwise would have. Nobody in Washington planned for that trade-off. Nobody planned this outcome. Not Washington, not Beijing, not the labs on either side. Two governments spent years trying to build walls against each other. What they built, in practice, looks a lot more like a bridge, and you've been walking across it this whole time. So now I'm curious, do you think the export controls actually worked, or did they end up accelerating the very thing they were meant to stop? Let me know in the comments.